Hi everyone, my name is Shixuan Guan. Today I'm presenting our paper titled Characterizing Ethereum Address Poisoning Attack. This is a joint work with my advisor, Professor Kai Li. It's an honor that our paper has been accepted by ACSESS 2024. Ethereum is the largest smart contract-based blockchain, which typically supports two types of addresses. The first type is called externally owned address, which represents a user's account on the blockchain. The second type is called smart contract address, which represent the deployed code on the blockchain. To facilitate user access to Ethereum data, Etherscan has become the most popular Ethereum explorer. Through Etherscan, user can check the latest blocks and the latest transactions, as well as search for user's transaction history and the token transfer history. Specifically, when displaying user transaction and token transfers, Etherscan shortens user's address to improve the UI's aesthetics, a practice commonly adopted by many other blockchain explorers. For example, Etherscan now only displays the first 8 characters and the last 9 characters of an address, while hiding the middle 23 characters. Due to address shortening on Etherscan, users often rely on the prefix and the suffix to differentiate addresses, which has exposed a new attack surface called address poisoning. In this attack, after observing a legitimate transfer, the attacker craft a transfer with a lookalike address to deceive the victim. The phishing transfer uses the same sender address, but the recipient address closely resembled the legitimate one, allowing the victim to mistakenly copy it and unknowingly send tokens to the attacker, resulting in financial loss. Motivated by such a new threat, in this work, we aim to answer 3 research questions. First, how prevalent are address poisoning attacks? Second, how many victims have been deceived and what is the financial loss? The last one, what strategies have been used to increase the attack success rate? By running to answer these questions, we developed a detection system called Poisoning Handler. This diagram shows our detection pipeline. So we have 3 modules here: data collectors, token analyzer, and the address filter. By running our detection system, we detect millions of phishing transfer craft by address poisoning attackers. Here are some key takeaways from our paper. First, we did the first in-depth analysis of Ethereum address poisoning attack. And from our result, it shows over 40 million phishing transfers and 6 million phishing addresses, and more than 1.4 million benign addresses were targeted. We found 3 different attack strategies, including dash value, zero value, and fake token. And we also found that the attackers tend to target the token senders, and the phishing addresses have more than 7 similar characters. Lastly, the overall profit is nearly 90 million US dollar from over 1,800 victims, and there are 4 big attacker clusters overall. Thank you. This is our paper.